Alright, so the, the next question we have is an optimization question of related rates. So there's three of us standing at this point here, and we see a taco stand right here. So the question is, one person wants to go like this, the most direct way. The next person wants to go all the way up to the road where we can walk faster and then across. And I'm trying to find the fastest way. So to start, we need to know what times these two people have. One going up towards the road and one just going straight across. So the person that's going up to the road has a time of 275.32 seconds. And the person that's going straight has a time of 325.01 seconds. So we know that if we go on a little bit of a diagonal to hit and then we hit the road, we'll have the fastest time. So I've set this equal to r, and now we gotta try to solve for r. So r is equal to 300, first we have to make our triangle. So we have x equaling here, and then we have our total distance minus x. And then we have our regular 325.6 still here. So now we have to figure out what r equals. So r equals the square root of 325.6 squared plus x squared. So now we plug this in for our optimal time. So our optimal time is equal to x squared plus 326.5 squared, all of the power of 1/2, which is basically saying square root everything, all over 2, plus 562.6 minus x, all over 5. These are our speeds. 2 feet per second is on the sand, and then 5 feet per second is on land. So our optimal time, we have to find out the vertex, so we have to find the zeros for opt prime. So 1/2, we're doing our derivative now. Chain rule, 1/2 gives you, you bring the 1/2 down exponent, keep the inside the same, minus 1 from the exponent, and then you take the derivative of the inside, which is 2x, and then you take the derivative of this, which is negative 1/5. So now we're just moving this down because it's our negative exponent. We can cancel out the 2's here, so we're just left with x on the top, and we keep the 2 at the bottom. So now we have x over 2 root x squared plus 325.6 squared, and then minus 1/5. So now we add the 1/5 over to the other side, so now we can start to solve for x. So now we have 1/5 equals x over 2 root x squared plus 325.6. So now we can cross multiply, so now we get both numbers on the top of our fractions. So we get 2 root x squared plus 325.6 squared gives you, or equals, 5x. So we're going to get rid of the square root, so we square everything. So now we have 4 bracket x squared plus 325.6 squared equals 25x squared. So now we multiply into our bracket, and we get 4x squared plus 424,061.44 equals 25x squared. Subtract the x squared from this side, bring it over. So now we have 21x squared. We divide this number by 21 to get x squared. Now we have to square root both sides to get just x. So 142.103491 equals x, or just 1.421. 142.1. So now we have this, so now we have to figure out our time. And remember, our time is r. So we have to use Pythagorean theorem to get r. So we do 142.1 squared plus 325.6 squared, square root of all of that over 2, plus 562.6 minus 142.1, all over 5, gives us a final time of 261.7286644 seconds. As you can see, this time is faster than both these two times, which makes us arrive at the taco cart first. Okay, so the second part of the second question is asking us where can the taco cart be located so that if all three of us take different routes, we can get there at the same time. And the answer is there is no way that all three of us can take different routes to get to the taco cart at the same time. But there is a way that we can take two different routes and get there at the same time. Actually, there's two ways. So first, you got to set up your equations. So 325.6 over feet over 2 feet per second plus x over 5 feet per second equals c over 2 feet per second. C is our hypotenuse of the triangle, which is the square root of 106,015.36 feet plus x squared. So we have our equations. Now we have to solve for our x value. So we can combine these two equations with the common denominator of 10. So we get 1,628 plus 2x all over 10, and then equals our square root of 106,015.36 plus x squared all over 2. So we can cross multiply to get rid of our denominators and get rid of our fractions. So now we have 3,256 plus 4x equals 10 root 106,015.36 plus x squared. So now we try to get rid of the x squared. So we square both sides. So now we get 10,601,536 plus 26,048x plus 16x squared on our left side, and then on our right side we get 10,601,536 plus 100x. We get this because when we square this side, we can get rid of the square root, and then we get 100 on our outside, and then we multiply in, which will give us our values for the right side. So now we can cross out the 10,601,536 from both sides, and we can move everything to one side so that we get 84x squared minus 26,048x. Now we can factor out an x from both terms, so we get x, and then we set the equation equal to 0, so 0 equals x bracket 84x minus 226,048. So we can get our x equals 0 from the outside, and then for our inside we get 84x minus 26,048. So we have to make that equation equal 0. So we move our 26,048 to the other side, then we divide it by 84 to get x alone, and x equals 310.1 meters, or feet. So we're trying to figure out it. So to prove that we can't have a third path in order to get to the taco cart, we can represent our optimization, which would be our third path, as a Desmos parabola. So our equation of our third path is the square root of x squared plus 325.6 squared all over 2 plus 310, which is our maximum length for our triangle, that they would all equal, minus x all over 5. So since one possible option is that the taco cart is directly above us and x would equal 0, you can't take the optimization of that because there is only one path there. But we can find our path to 310.1 feet. So our quickest way would be to go across and then over, but we don't want that. We want the route that would be the exact same as C. Unfortunately, there is no option because we have right here. So our time to get to C is 224.8 seconds, and in order for us to achieve a 24.8 second mark, our path has to be at x equals 310.1, which would mean we're just following in C's footsteps. So that that's why we can't have 3 paths. So in conclusion, you can either go straight up so that x would equal 0, or you could go across and follow c so that x would equal 310.1, but there's no way that you can have 3 paths.